All right, so we're recording. We're back to system software. So first of all, questions from last time. Last time, remember, we went over the very basics of the command line. So if you've never touched the command line or had to type anything into it, hopefully that will give you a little crash course. I went over a lot of the really common kind of core Unix-like GNU or Linux-like commands that you'll use constantly on the command line, and some speed hacks, some tricks for making it fast. So what was the most important one that I went over last time? The most important thing to remember on the command line? Tab completion, autocomplete. Use it often, just by muscle memory. Just hit tab all the time. All right, any questions from the command line lecture? Okay, pretty straightforward. So who actually went out and used the command line? I hope everybody. So there was a homework for it. All right, so the homework was to, well, I guess, so first of all, any questions on homework one? Homework one was just connecting to use this. Has anyone not connected to use this? Is anyone still waiting? There were some answers about the VPN troubles that people are having. So talk to IT, look on EdSTEM. Anyone still having trouble with VPN for off-campus stuff? One person. Okay. So I have office hours starting today. So come to my office hours or look on EdSTEM and to find some help with that. All right. So homework two, actually using the command line. So I know for some of you this may be easy. It's maybe review. But for many of you, you never really had to use the command line, especially in college. So first of all, any questions about this assignment? Yeah.
As far as the submission was concerned.
Submission?
As far as because it asks
oh, yeah.
exact commands for it.
Yeah.
For future, do you want us just to copy paste the history tab into a separate document, or would you rather us take a picture of the final results? Or?
Any would be okay as long as it shows a sequence of commands. I was just expecting text. So I think maybe I'm old now, but to me it's hilarious to take a photograph of text because it's thousands of times more data that you need. You also can't cut and paste it, so you don't need to take screenshots of text. You can just highlight the text, unless the formatting really matters. But I find it very funny. You can just put text. We already have a representation for text that's data is pretty cheap nowadays. But you could take a screenshot. You could cut and paste text. You could run your history command if you remembered how to do that and get your history of commands. Any of those would be fine. Yeah. Yeah, absolutely. You put the list style. Yeah, totally fine. As I said, homework is not meant to kill your grade. It's meant to be an easy way to get points and make sure you're keeping up with the class. So it's not going to be graded for 100% accuracy. So I've instructed the graders to, if you have anything reasonable there, something that's genuine effort is my subjective, non-quantifiable way to say it to avoid, gaming it. But don't put a blank submission or just say hello or something. But generally, if you make an effort, you'll get points. And they're not supposed to take more than on average an hour or so. Sometimes it might take longer, but I've tried to make these pretty fast so you can get them done and not have your grade hurt by it. Other questions on the assignment? So there was definitely some questions on EdSTEM. Sound. How do we? So here there's no sound file, and here there is a sound file. Now here is sound a file, or what do you know about this looking at the street? Do you know whether it's a file or a directory? This is a trick question, yeah. It's blue?
Into the tree that you download, it's blue, so
oh, okay. All right, very good. So there's a little side channel there through the color. But it was kind of a trick question because directories are files as well. We'll learn about this more when we get to the file system. So it's definitely a file. All of these are files because directories are files. But if you saw that by the color coding of my machine that I had apparently, it was a directory. So I probably had it as a directory when I created this. I don't remember what I did. But the trick question there is that directories are files. And so it doesn't matter. If some people ask about this, it doesn't matter. Because the tree, at least as written in the homework, doesn't distinguish. Both are files. So how could we create this as a directory? What's the command to create this as a directory? Yeah.
mkdir.
Yeah, mkdir, make directory. What if it were a regular file instead of a directory? What would you use? Touch. Okay, good. So I even gave you the commands doing this. Questions on this assignment? Any questions on the assignment? I mean, it's a little puzzle solving too, because you're going to have to compare the two. They can go in any order. Think of it as a tree. I mean, it really is just a tree, and trees do not have order, at least the kind of general tree that you probably learned about in CS1 or CS2. They're unordered, right? The children are unordered in a standard computer science tree. All right, questions on this? Questions on the homework? If no questions, I'm going to assume everybody's a master at the command line and ready. No, I'm just kidding. But these are the main things you're going to use to manipulate your file tree. So for instance, if you're testing a C program and you have a test case, don't overwrite the file. Now you have the power on the command line to save it, move it around, rename it if it's a bad name. Now you hopefully should be able to be more of the tortoise, where you can save a lot of files. You can very quickly have a workflow on the command line and avoid some of the things that are going to slow you down using the command line in this class. All right, other questions before we begin the main lecture? Yeah.
Actually, could you reiterate the whole star thing? Because I remember trying to read it directly and the model rating and whatnot. Why exactly are you doing it?
Oh, okay. So why can't you? So this is just a decision by the creator of the remove command. So the remove command it's a program. It's a program that somebody wrote, and so they made the decision that remove will not remove directory files. And the reason for that is because directory files point to other files. So if you delete the directory, you lose a way to access through the file system all those other directories. So someone made the decision that remove star, or remove actually only works on regular files and will not remove a directory unless it's empty. So star I didn't go over it too much, but star is a wild card that will expand to all files in the directory. It's kind of like autocomplete, where if you give bash star, it'll replace it, it'll look up the directory and all the files in the directory and replace it with the list of all those files. And so that's unrelated to why remove will not remove directories. If you put remove in a directory name and that directory is not empty, remove will also refuse to delete it. So this is just a choice to avoid, mistakes, sort of irrecoverable or hard to recover mistakes where you trash your file system by using the remove star command. So there is a flag that will tell the remove to force -F, and I think -R for recursive. You can tell remove to do that. It has a feature to do that. But by default, it won't do that. But it's just a design choice. Does that answer your question? Okay. All right, let's see if I'm going to break anything by turning off dark mode. Okay. All right, other questions? Yeah.
Is it possible to remove the directory and still accidentally keep the files it's referenced to? Or
It's
referencing it?
Yeah. So the directory is, we'll learn more when we learn about files. The directory is really just like a phone book. It has names and the file numbers. So if you move that directory file, you still have pointers to all of the other files that are in the subdirectory. So that's why. So moving the move command does allow you by default to move directories, and it's as if you're kind of grafting a part of the subtree onto another part of the subtree. If that makes sense. Grafting is like trees, where you take branches of an apple tree and put it on a different apple tree. You take the whole subdirectory and put it under a different directory when you do move directory.
I was asking, can you create a memory leak in a sense by removing directories and having files that aren't referenced?
I see what you're saying. Yeah. So this is called in the file system world. This is called fragmentation. So if you ever had to run a defragmentation tool, anytime you delete a file, you have so-called fragmentation because all the data is still there on disk. And so just like did you guys have to learn about malloc, how malloc works? Oh, okay. So it's not unlike malloc. So there's a table that depends on the file system, but the file system manages which parts of the disk or which parts of the storage medium are free and not free. And so you won't lose the ability to overwrite that data as long as the file system is correct. Does that make sense? Yeah. So if the file system doesn't have a reference to it anywhere and it's written correctly, then it's not considered data. It can overwrite that data. So it's considered free space by the file system. Does that make sense?
What if you don't remove the reference to the file, but you remove the reference to the folder? So you have a file on the disk you only.
Oh, I see what you're saying. So did I have you guys read this? I can't remember when I have you guys read this. Okay, so it's not till here, but yeah, the name of the file, the number of the file is called the inode. And I think what you're saying is if you don't delete the inode, but you delete the reference to it, do you have a leak? I think so, yeah. I think the file system is supposed to protect against that. But yeah, you would have data that the file system thinks is allocated, but no one can read. So I guess that's possible, but I think that would be a bug. I think the file system developer would think that's a bug. That's also why I think in the Unix world, well, all right, again, we're talking about the file system, but you can have multiple names for the same file. They're called links. And you can't do that with directories, because directories, that would give you cycles. Anyway, we'll ask me more about that there. We'll talk about links and cycles and hard links and all that when we get to files. But in principle, no. If the file system is written correctly, no. You shouldn't have unreferenced, non-free space, as far as I understand. All right, other questions? All right, let's try attendance. So I'm going to stop recording because I don't know. Today we're going to talk about version control. So who has used version control? Was it for class? Was it for yourself? Is it for yourself? Okay, that's good. So a little, like a quarter. Okay, that's good. So some people have experience with this. Where's my, okay. All right, so version control, source version control is not a programming language or a programming tool per se. It's a software engineering tool. It's a tool to help you manage your software. And I think pretty much anywhere you go, if you're in any kind of tech shop, even for documentation, other types of projects use this, you're going to be using version control. All right, so what is version control? Version control just records changes to code. That's it. So why would you want to do this? Why would you bother keeping track, logging the changes to code? Why would you want to do this? Yeah.
What if you're trying to fix a bug and then you fix it and you find that controls something?
Yeah, so regressions. We talked about regressions, right? So, being slow and steady, you can still have regressions. You can fix a bug and you make a new bug, or you reintroduce a bug. So having a log of what happened will make it much, much easier to do that first step in debugging, to find where the bug happened. Actually, was it my second or third step? That's one of the most important steps in debugging, is to figure out where in the code the stuff went wrong. So if you had a log of all the changes, you could look through that log instead of looking through all the code. So if you had 20 million lines of code, but 20,000 log messages, it's fewer things to look through. And there are actually automated ways to help you look through code. Any other reasons we might want to log the changes? Yeah.
Everything is good before, but then you break prod.
You break production, break prod, break production. Same thing. So, and if you for break production, you had a record of what lines actually changed, it'd be much easier to try to fix it, right, than trying to go through the whole code base, especially if lots of people are doing development. Any other reasons you might want to use version control? Yeah, back here.
Like a lot of the times we'll be working with like a team of people, so it's important to keep track of like who does what and like who changes what, so that you can like cross check with them. Like,
and blame them, right? You can blame them. You can, yeah, exactly. Yeah. Git has a tool called blame, which will show you who made what the most recent change on code. So okay, great. So it sounds like you guys have a really good sense of version control. So these are some, I think you captured most of the reasons here. So when you have a lot of people working together, this becomes really pertinent to be able to track who's doing what, and also to make sure that people's changes don't conflict with each other. If you're working on a similar part of the code base or you have overlapping changes, you want to make sure that you don't have the classic ABA problem where you save and you overwrite somebody else's stuff. Who's ever shared code by just like copying a file or sending it over email? Okay. Oh, yeah, okay. Good number of people, right? So if you actually do that collaboratively and like two people made changes they try to send, well, that's going to be kind of disastrous. Or if you've ever had to had 10 people sign a document and you have to send it one by one. So version control helps account for this as well. And also this, what people already pointed out, rewind the history to prior versions. So you can kind of, instead of having whole files that you passed around, you have a history of changes that you can literally turn back time and see what that code looked like exactly at that point in time. And it gives you accountability, so you can blame people. All right, so the analogy I like to use, that I think everybody probably knows, is your bank account balance. So if your bank just told you, hey, you have $31 right now, and you don't think you have $31, you might be a little suspicious of the bank, right? You might say, well, I think you got this wrong. It's much, much easier to see why you have $31 if you have a transaction log, right? You all seen this. You've figured out you spent too much money on beer or whatever, or maybe you guys are too young for that. And you're like, oh man, I really don't have this much money. The bank's not lying to me. I have this transaction log. And if there's a mistake, and you just tell your bank, well, no, I should have $60. Well, they're not going to believe you. But if you say, well, this transaction here, I did not buy gas here. This is 10,000 miles away. I didn't buy gas here. Then they can remove that transaction log. They can trace where this debit or credit came from. And so the key here is that we don't even need the total. If we have the list of transactions, then we have no need for the total. How do we get the total if we have the list of the transactions? You add them all up, right? So did I do the math here correctly? 42 plus negative 15, what's that? 27, is that right? Did I do this right? 27, and then 21 plus 10, 31. So you don't even need a total at that point, right? You can just keep the sequence of changes. As long as you start at 0 or you know the starting amount, then all you have to do is add and subtract the amount of money and you get the total. And so version control systems work very much the same way, at least conceptually. Under the hood, they may operate differently, but conceptually, you start from basically a blank directory. And if you have a list of all of the lines of code that was added and removed and all the file names that were added and removed, you don't even need a snapshot of the source code, right? You can just keep track of the deltas, the changes. And that's conceptually how version control works. You record each version of your source code to a log, and at the same time, you give metadata about that change. So who did it, what time they did it, what the previous code version was. So you link to the previous version. So just like here, if we're at this point, we need to know that 42 came before it. There's an ordering here. So if you change the order, the sum total may differ. Well, so arithmetic is associative, so it doesn't matter the order that you do it. But if this were code, the order would matter. So because you might have the same line of code being changed. And by convention in version control systems, you also put a message. You also describe your change. And now, when you're using it in this class or using it informally, you may just say updated. You may put some really bad, unclear message. But in professional version control, developers are required by their job, if they're at a professional place, to clearly describe what the change was. So give accurate metadata that will help people who are looking back in the log understand what happened. We're not going to go too much into that in this class. I think I've linked to some guides. So Google Engineering has a really good guide on good version control usage. You can, it's just a tool. You can use it poorly as well. You don't have to use it to its full power, but there are, if you go to an internship or you go read Google's guide or other guides, there are optimal ways or good practices for using these version control systems. But basically what you get is you get a change, a list of changes, and a message that describes those changes. All right, so these are based on, these are all based on a tool called, a set of old tools from the Unix world called diff and patch. Who's used diff before? Who's used diff? Not many. Okay, so this is also a really useful tool. Version control will do this for you, but diff will show you the changes between two files. So, all right. So I've got this file here, and let's say I do the old style of version control, and I just copy this to my friend and ask them to do some development on it, and they want to change capitalization and punctuation and add a comment. So now I've got two files, and they look pretty similar. But instead of having to manually go through and figure out the differences, I can run this tool called diff, which I think stands for difference, and it will show me only those lines. By default, it'll show me only those lines that differ between the two files. So this left arrow, there's different ways to configure the output. This is one of the default outputs. This is the default output. The left arrow means this line appears in the first file I gave. These arrows mean these lines appear in the right file. The Git and other version control systems use a different view of the diff tool, which shows you pluses and minuses instead. So minus means line removed, plus means a line added, which is much closer to our bank transaction log. So you can think of diff as giving you one transaction on code, all the subtractions and all the pluses, just like in a bank account. Questions on this? Questions on what this view means? So these pluses and minuses show us which code has changed between the two files. Minus means it was in the previous file and removed in the new file. Plus means it was not in the previous file and now it's in the new file. Yeah. Are there more diff views? Yeah, I think so. Yeah, you can actually configure it to give your own view. But I think there are. Yeah, I'm sure there are more. I mean, you can look at the man page. Oh yeah, actually one that I use actually frequently is -y, which shows you a side-by-side between these, which is pretty useful, and it gives you other markers to say changed or added or removed in one file. So diff-y is, I use this one actually kind of frequently to look manually at stuff. But diff-u is the one that's the kind of more version control, the one that's Git, for instance, shows you by default for version control, and it has this nice analogy to the bank transactions where we have plus and minus code. All right, questions on this so far? What this diff means? So we took two files, hello.c, and my other file, new hello, that I modified from hello. And diff will show me all the files that were added and removed in the new file, in the right-hand file. So this tool can be used in conjunction with another tool called patch. And a patch is just this text. So this -u is a unified format that was created by convention. But this is also a patch file. So if we have the old version of the code and we have the diff, just like with your bank account, if we have the current bank account and we have a transaction, we can find the new total balance. So here we don't even, so if we have one version of the code and we have a list of all the changes, just the diffs, then we don't need to have the latest version. We can just take all the diffs and add them to our code. And there's even a tool in the Unix world called patch that will do this for you. It'll take a patch and it will give you the new version of the code. So before I show this, let me diagram this a little bit to make this, get you conceptually to see what this looks like. Okay, so we've got our original file here, and we have our new file, new hello. The diff tool will give us a patch file. And with this patch file, we can construct, if we have hello.c and we have hello.patch, the patch tool will give us the contents of new hello. Questions on that? Does that make sense? So as long as we have the set of differences, we can always recover the latest version of the file. Questions on that? Does that make sense? So to kind of put these all together, we've got the old version, the new version, and the patch file. And we can take these two and recover this file. We can take these two, find the patch. And we can actually also take the old one, the new file, and the patch, and reverse the patch as well. We can invert the patch, like changing plus to minus. So we can actually reverse the patch as well. So as long as you have any two of these, you can recover the third, just like in math. All right, so let's see this in action. So I've got my patch file. There's my patch file. I have my original file. So let's recreate new hello from the patch file. So I'm going to take my original hello file, patch.hello.c, and I'm going to use the patch tool to apply the patch. So I'm going to take hello.patch and save it to my patched file. All right, let's take a look at hello patched. Oops. Oh, it actually overwrites the file. That's why I had copy here. All right, I need to reverse. I need to reverse the patch because I just overwrote. I just overwrote my file here. All right, so you'll see me reversing the patch now. I think it's -R. Capital R. Let me undo the patch because I blew away. So it overwrites the file, which I forgot. That's why my instructions here copied it. So here's my original hello file. And let me patch original hello with my patch file. So this is original hello with the patch file. When I run patch, now my original hello file is the new hello file. So to prove that, I can use diff again to show you that now the original hello file has been patched to the new hello file. So nothing is output. Questions on that? Does that kind of make sense? Questions on this? Yeah.
What was the patch file that you created? Was it just a copy of the original hello?
No, it's just literally the output of diff.
Oh, okay.
The patch file is just whatever diff outputs.
Okay.
That's it. So in this case, it's not very efficient because it has the entire rest of the file here. So by default, this unified format will show context of the file. But if we have a large, code base, let's see if I can show an example of a patch here. Okay, that's not a very interesting one. Also not interesting. Let's go back in time here. These are all merge requests. Oops. So here's an example of a patch file from my work where it's only a single line change. So one line was removed, one line was added. So diff does not show you, this format does not show you a changed file, a changed line. It just shows you one line was removed, one line was added. But this file is much, much larger. So it shows you a little context, the stuff that doesn't have any plus or minuses before it. This is a much larger file. It's like, I don't know, a couple thousand lines long, I guess. 1,300 line long. So I can use the WC command to tell me how many lines there are. So this has 1,300 lines, but this diff only shows one line added, one line removed, or one line removed, one line added. So it's much more parsimonious than copying the whole file. All right, questions on diff and patch? Yeah.
So just to clarify, if you're patching an old file with the newer one, you would get like the other one.
If you patch a new file with the patch, you'll get the new file. So this is this relationship here. So if I, how can I show this? So let me use a different color. So if I patch, if I run patch with these two files, I get the new file. If I run diff with these two files, oops, I get the patch. That's very ugly. This is sort of hard to draw on the fly. let's not show it together. So patch will take the difference file, the file that came from diff. So this is produced by diff, and it's just the set of changes. So it's this file here. This is the patch file. It's like in your transaction history. It's one transaction log in your bank account, and if I add that to my old balance, I get my new balance. And just like in your account balance, if you take your new balance and your old balance and you subtract them, you get the transaction, you get the amount of the transaction. So if your bank only showed you your total and you didn't know how much you forgot how much you spent, your old total was 31, your new total is 40, you can figure out that your transaction was $9. Yeah.
And when you did that patch file, there's automatic, you can always have the dot patch.
The file extension is set by you. So we'll see this when we talk about files, but the extensions are not intrinsic to the files. I just gave it that name. But the output it gives you is this output when you run diff-u, the unified format. I saw other questions? Yeah.
So as long as like the file context, like hello patch has like the diff output, it will work regardless if it's not named hello patch.
The name is irrelevant. The name is irrelevant. It'll work, yeah. The patch file just takes in text. These are all just text processing tools, yeah.
When we run diff, does it automatically save the patch file, or do we have to create a file?
Diff by default writes it to standard out. Again, something we'll look at when we look at the Unix philosophy. So all these tools, these Unix tools, always write to standard out and read from standard in. So if you used printf, you were writing to standard out. You didn't tell it where to write. You didn't say what file to go to or anything. I didn't show redirection. So I can tell Bash where to put the contents. So when I ran diff originally, this little arrow said save the output into this hello.patch file. So by default, no, diff will just write to standard out, and then it's up to you, the user of the tool, to tell it where to put that contents. So this is a consequence of reordering my class, where I didn't talk about processes yet. All right, other questions on diff? So it's good that this is pretty essential to understand the version control, and to also kind of get your mind out of I need to save a whole file, or I need to copy a file. If you're probably used to that, because this is the way our file systems work. They work with whole files. Version control is like a different kind of file system, a diff-based file system, where you only work with changes to files. And when you actually start using this, you'll start realizing some issues. So for instance, if you start working on your project and you're like, oh, I made a mistake, I'm just going to delete it and redo the project. The Git server is not going to let you push new changes. It's not going to let you push a new history of changes. So for instance, if you were like, I don't really like my bank account history, I'm just going to tell my bank a new transaction history. They're going to say no, right? They're not going to let you do that. But you can always change your current balance by adding new changes. So let's say you add a bug. You don't need to go back and reverse history and delete the whole repository. You just make a new change that undoes that bug. You see what I mean? So let me illustrate this more concretely. So here's my latest version of the code. I guess. What is the list? Oh, new hello. Actually, let's do it this way. So here's my original version of the code. Here's my patch. Now, let's say I didn't want to reverse the patch. I just wanted to, and here's my patched. Let me patch the code again. So I've just copied the original to a file called patched, because patch is going to overwrite it. So I'm going to overwrite this file with the patch. So now my hello patched file, this is my new version. Right, it has my changes. So instead of having to restart from scratch, I could just go in and I could just undo the changes that were made in the file. So I just put it back to what it was originally, and now I can diff that file with my, I deleted it. So this is much easier with version control. You don't have to do this stuff manually. So I'm giving these horrible names for this. So I'm going to make a new version of this program where I've modified it to put it back to what I think, to undo whatever my collaborator did. And now you can see that from the patched version and these names are getting really cumbersome, which is why version control is really useful. Let me use this format. So it's actually identical to the patch. So this is the original patch. It's identical except the plus and minus are reversed. So I've added this line back where here it was removed. So let me save this as, I'll call this patch 2. So you can see these names are already getting really terrible. So now I need to apply this patch. And this is, again, getting really cumbersome. This will be much easier with version control. So I'm going to take my new version of the file. Wait, what am I taking? Let me just take new hello. This is the one I wanted to patch. So I take new hello, and I'm going to patch it. So let's patch new hello with my version 2 patch. So now new hello patched is just back to what it was 2 versions ago. All right, I know that's really convoluted. Version control is what actually helps manage this automatically, tracking this kind of change. So I had to make a bunch of temporary files to keep track of each patch, and I had to come up with a naming scheme, keep track of each version of the files. This is what version control does for you. It manages and records each of these changes for you in a system with tools that will allow you to create them and access them. And that's exactly what Git does. So this looked really cumbersome. I don't expect you to entirely follow it, but the point here was that I didn't have to roll back history or recreate a new file. I can just take the original patch I had, which added this comment and changed lines, and I could just make a new patch. I could just make a new patch that reverses it, and I get to the same spot. Questions on that? Does that make sense? So you don't need to copy a whole old file and put it on the Git server. You can just make a new change. All right. All right, so that's Git and patch. That's the kind of historical tools that underpin this, the Git tool, which actually uses them or uses their outputs to present to you changes. Okay, so the version history that's stored by this version control system is just a sequence of these diffs, effectively. Under the hood, Git works a little differently. It actually works like a file system. But the interface that's presented to you is a sequence of diffs. Now, I've dramatically shortened this lecture, although it may not seem that way, from last semester, so I can get into the exercise. I've made a much more detailed exercise that I really want to go through to help you understand this tool. And so I'm just going to give you a really quick overview of Git, and then we're just going to get our hands dirty and start using it. So this book is a great read if you want to learn kind of basics of Git. I originally had more content from this book in here. But basically, there are 4 sections of your version control system, 4 stages that they can be in. You have your working directory, which is your local file system copy. So this is what you're actually going to be editing. So we've got your working directory. So here's your working directory. This is where you're going to edit your files. This is what you're going to actually change your code base with. And this part is kind of unique to Git. It's called the staging area. So staging area is where you can collect changes that you want to commit. And there's good reasons to do this. If you are making lots of changes to your code, as you might be working on multiple bugs, or you might have some changes you don't want to release yet. Maybe you have some comments in there or some debugging code that you don't actually want to commit. Then staging area is where you tell Git, here are all the lines of code that I want to add to the diff. So this is your staging area. And then you have the repository itself. And this is actually stored in a subdirectory, a hidden subdirectory called .git. So by default, the Unix tools will not show you files or directories with the list command that start with dot, like dot and dot dot. There's a little folder called .git, and this stores your actual repository. This stores all the changes, all the diffs, all the records. And so the workflow is that you make your changes in your local directory. So you edit your hello file, and then you tell Git, okay, I'd like these particular lines of code to be added to my commit. And then once you're done collecting those together, you say commit, make a new change. And as soon as you do that, Git is going to ask you for a message, a log message, to describe your changes. Just like in the bank analogy where you have a description that says this is the merchant, this is when it was spent. Git will add that metadata for you along with your message describing it. So we have working directory, which means your code is modified. We have the staging area, which means your code is staged. And we have the repo itself, the repository itself. I'll use repo as a shorthand, where when you actually commit your changes, that's where they're stored. All right. So Git is also a distributed version control. Oh yeah, go ahead.
Does Git work like when you're staging? Do you stage on a line-by-line basis, or do you stage on a file-by-file basis?
So in the underneath the hood, or at least the conceptual interface is that it's line by line. But I'm going to show you how you can just do the whole file. So if you want to stage the whole file, you can just give it the whole file name, and it'll do all the change lines in there. So in practice, that may not be what you want to do. If you're going to a professional development, let's say you had some debugging code in there, some ugly comment, or you were frustrated and you wrote some curse messages, you probably don't want to commit whole files. You may want to, and doing this on the command line is a little onerous, so I'm going to still make you do it on the command line, but you can do whole files for this class, because the files are quite small, and your development is probably not going to be that complicated. So you can do whole files. You can just say, give me the whole file. And in fact, if you run commit, it will actually state the whole file if you give the file to it. And so I'll show you the commands for doing that. But just remember, conceptually under the hood, you're not committing files. You're committing changed lines in that file. That's why I want to kind of belabor this a little bit, because especially last semester, people were still thinking whole file. They would say commit whole file, and they'd think they're committing the whole file. But in fact, they're just committing the changes, at least conceptually. They're just logging the changes to the system. Git has a system for actually, storing whole files, so it'll very quickly snapshot, be able to check out snapshots. But conceptually, you should be thinking in terms of changed lines. All right, and there are commands that correspond to doing each of these tasks. There's add, which stages them, and there's commit, which creates this log in the commit history. So this is what this looks like in the repo here. What this looks like is we have an initial commit. So you might have, so the structure of a commit is a diff. There's a diff area, and then there's a message. So you, the developer, might say initial commit, and then conceptually, what's stored there is the output of a diff here. So the diff from nothing to something is just all of the lines of those files. And then when then you change more stuff in your working directory, you stage it, and then when you do another commit, you can think of this kind of like, if you've ever heard of blockchain. Blockchain is a similar idea where you have a set of changes with metadata. Here's my message describing my new change, and it points back to the previous diff. So with this sequence of diffs, you build up this long sequence of diffs, and this is just like the transaction log in your bank. This is the sequence of diffs. If you add all the diffs together in order, you'll get the latest version of the code. Questions on this? All right, so what's the remote repository all about? So in the diff world, actually this might be a good place to use the textbook. So I had this up before. Where's the... So they had a good picture of the remote. Maybe it was in the beginning. Oh yeah, here we go. So Git is remote. Each of these, Git is distributed. Each of these is the personal .git folder, the personal repository on each computer here. So you, the developer on computer A, might have your own local repository. That's the .git folder. You've committed your changes here, and so here's your database of versions. So these are each of your commits. And another developer may also have a full copy of that database. So they can share their changes by using a common server, or they can communicate with each other and pass changes around. Yeah.
How does Git handle like a merge issue?
Yeah, so there's a tool called merge, and it will, by default, attempt to, so if there are basically no lines that conflict, it'll just add them all together effectively. And what you end up with is a kind of a bubble in the merge history. So there may be multiple developers' changes forking from, I still have that on. There may be multiple changes forked from the same underlying change. Whoa, what's going on? Uh-oh. I have some system craziness here. What is going on? Okay, this is not working. This is frozen. Uh-oh. All right, this thing is not working, so it's going to be my even uglier. Oh my God. Okay, I don't know what this is doing, but you basically get two. Yeah, this is not. Oh, am I just being dumb here? No, this thing is like fighting me. It's turning to a race mode whenever I go to write. Oh, there we go. So you get a kind of a bubble in the history where there are multiple developers making a change to the same version, and then a so-called merge commit, which combines the two. Now, if there's no conflicting lines that are being changed, and the developer asks for a merge, it will just add all of them together. If there are lines that were changed by both developers, it won't finish the merge. You'll have to manually go in and do resolution of that merge. So it's called a merge conflict, and they're very, very annoying. But there are best practices for dealing with these kind of changes. But yeah, good question. So we won't have to deal with this in this class unless you don't follow my directions and you make lots of versions of your repository. In the past, I used GitHub, but students would upload whole files to GitHub, and then they'd give themselves merge conflicts on their own machine or on Eustace. And so that's one reason why, because I wanted everyone to do the command line, but people would kind of subvert that. So you shouldn't have merge conflicts if you just follow the directions very carefully and don't make multiple versions of the repo for you. But Git does support this so-called distributed version control. And to the Git tool itself, there's neither of these versions are like the official version. The developers outside the system have to say, well, this is our kind of official version that people can pull from. But each of these machines has a full copy of the entire repository and is the real copy. Even if they might diverge, they're all their own real copies. And the developers have to organize the system in such a way that they decide on which one is the real copy. So who's ever heard of like a forked software repository? Like I use a fork of this software. Well, that's just somebody saying, well, my version is now the real one, and yours is not. Maybe they give it a different name on GitHub or something. But they just have the same Git history, and they've diverged and just not merged, basically. You can think of it as this indefinitely, where you don't merge changes anymore, or you only merge some changes. Okay, so that's the remote part, and we're going to use that in a very limited way in this class. We're going to use the remote repository. So what I'm going to do for you guys is our server, our Git server, is the kind of official one. This is our grading server. So instead of having web courses or any other software for grading, you're just going to use Git to push, to synchronize your local repository on Eustace to our grading repository. So you'll use this in a limited way, and I'll show you the exact commands to do. But you'll use this in a limited way, the distributed version, in order to submit your changes for us to clone. Because then our grader will just clone from our grading repository all of your code, grade it. It also means that with Git tools, you can verify exactly what we see in the grading repository. So if you have uncommitted or unpushed changes to your own repository, you can very easily just go to the remote repository, get the current version that we see, and you'll see, oh, well, I forgot to commit that, or I forgot to push that. You also have the scripts, so you'll be able to grade yourself. So you'll be able to see exactly what we see. Maybe not the test cases, but you'll see exactly what we see. All right, questions on this so far? Questions on this? All right, so these are the commands we're going to use. We're going to use Emacs, not Vim anymore, Emacs, add to stage the file, commit it to your local repository, and push to synchronize it with the remote repository. There's also a command pull to get changes from a remote repository, but you shouldn't have to use that very much. All right, and then let's go into the exercise. So I have not done this in full real time, so real-time demos are always a little iffy, but let's see if this actually works. So I tried to make this as detailed as possible. I show you all of the outputs. Often there is no output when things go correctly, and I showed you the outputs of several common mistakes that I noticed students making. All right, so here I am on Eustace. I put in red here the stuff you need to do first, so you need to make sure you can get to Eustace. And I put some other notes to look at here. So when you configure Git, you only have to do this once on Eustace for the whole semester. So, all right, I'm going to configure Git really quickly here. Just follow the directions here. You only have to do this once. Just follow the commands. You can I put a command here you can run to validate that you've gotten it correctly, so that you will hopefully not skip any steps, and you'll see what it's supposed to look like. So I've set my name. I've set my email. I'm going to set my email address. And here's the validation step. You should see your email address. I'm forcing everybody to use Emacs, or kind of suggesting it. Confirm that it's Emacs, and set the default to master. It's already the default in this version of Git, but this will avoid if you used your own personal version of Git. This will avoid any issues with us grading. Yeah. Yeah, you can do your full name. Yeah, this will be visible by the graders. Yeah. Yeah, you should use your school mail. It's just metadata. It's just going to go along with the commit messages, so it doesn't matter that much. But you only have permission to write to your own set of repositories on the system. All right, so let's start constructing our Git repository. So this is the instructions that you'll follow for every programming project, exercise, or project. But you only need to do it once. That's the critical thing here. You only have to create a repository one time. If you create another one, you won't be able to push both to the grading repository. So only one will get pushed, and then you'll get rejected. So I think I have some output to show you what that looks like. All right, so I've made the directory here. There's not going to be the output if you successfully make the directory, but you can run the list command to validate that this is here. If you see something like this, like this, then it means you didn't create the directory. Go back to that step. Questions so far? So I have command, what you can do to validate whether you got that command correct, and then common error messages. And it's kind of like a choose your own adventure where you link back to the previous step. All right, so let's enter our Git directory. You can validate it with this command. Don't worry too much about the actual command. It should say your NID and then this path. All right, so here's where we're actually going to create the Git repository, and it's super uneventful. It just says initializing empty Git repository, and you can see the path to my Git folder and then .git. .git, remember, is the local repository. Maybe these names are a little confusing in hindsight. So Git is the name of your folder. This is the project. All Git repositories are called .git. Okay, so you can validate that you have a Git repository with Git status. Git status, you use this a lot, I hope. So this will show you whether changes are in your working directory, whether they're staged, whether they're committed, whether they're in the remote repository. So all 4 of those parts of your repository will be, you'll get a little quick summary of where your changes are using Git status. So you use Git status frequently to tell you where you are. So this is what you should see. If you see something like this, you didn't configure Git yet. If you reinitialize, you probably just ran it again. There doesn't seem to be any harm in reinitializing. All right, so here's where we're going to create our first file. So I'm not, so you'll see. So I'm going to create a file using the echo command. It's just a way to write a text file. So you can confirm that the file is created like this. And you can use cat, what we showed before, to see the file. So here's the contents of the file. All right, so now let's see what Git status tells us when we have new changes to our directory. It actually tells us that, hey, there's files that you've never told me about. So if you think you've committed, try to commit your repository at this point, it actually won't commit an empty one, we're not going to see that file. You may think you've done it, but we won't see it. The remote repository won't have it. Questions on this so far? Questions so far? So we've created a new file. We've created a repository. So if you see not a Git repository, it means you didn't run git init. So go back and initialize your repository. All right, here's where we're actually going to start using our the tools in our Git, uses the phases of Git, our components of Git. So the add command does what? What does add do? Stages. So we're going to stage this file. And so by giving the file name, it tells Git to use all changes in that file. So what, like your colleague asked before, if you give the file name to these commands, it'll just take all of the changes in that. But be aware that under the hood, it's looking for the changes of those files. And you can actually use these tools. There are flags you can give add to go through. It'll go through interactively and list every line if you'd like to do that line by line. But I'm not going to make you go through that. I don't even do that. I use a built-in tool in Emacs to do this, to help me do this. Okay, so if you run git status now, so notice we had untracked files. Now we have changes to be committed. That means they're staged. So they're not committed yet. They're in the staging area waiting for you to tell Git that you'd like to actually make a commit here. So this is what you see. So again, if you have these errors, go back and repeat the steps. Make sure you get them right. All right, so just to double check, so by default, you're going to, the editor that it's going to, so when you commit this, it's going to open up an editor immediately. And by default, that is Vim. And Vim is a bit of an esoteric editor. It's hard to, it doesn't tell you how to exit from it. So you may be very frustrated and just close your terminal. So that's why I have you just double check that you're using Emacs, because I have instructions for Emacs here. So make sure it's Emacs. And here's all we need to do to make a new commit. Git commit, name of the file. So just like with staging, this will do all the changes that have been staged in this file. Actually, it'll do all the changes that have been made in your working tree as well. Okay, so here's what happens when we run commit. An editor pops up immediately, and it gives you some text. These are comments. These are not going to go into your commit message. They're just sort of status information to help you see what's going on. So without doing anything, you can just start typing the subject line of your commit. So I think I've given a link here to good practices. So if you want to learn more about software engineering good practices, this is Google's engineering's guide to writing. They call them, I think they're called change logs. There's a guide. There's good practices for doing this. I'm not gonna check this or anything. I'm gonna give you some good practice here. So I just recommend saying added a readme.md file follow the directions for Emacs to save and exit. So I wrote here how you save and exit. And this is what you should see. You should see a confirmation of the fact that you've made a commit, the commit message, as well as this. It's a unique ID that's created for commit. That'll be different for you, but the rest of this should be the same. So it gives you a little statistics about what happened. One file changed, one line inserted, etc. Questions so far? All right, so we've already made our first commit. Yeah.
What's the benefit of using like the Emacs versus, I know Dash is really like common.
Yeah, so, well, the benefit is that, so Dash M is sort of bad practice because it sort of discourages thoughtful commit messages. So your commit messages really should be a subject line followed by a space and then prose or other text about, bullet points, text about the change. So if you read this, so it says it here actually. So for a summary of what should be done, short describing it, followed by an empty line, and then the body. So if you do this with Dash M, you can do it with like escape lines, but it's good practice to pop up the editor because it gives you time to think and write a good message. Because when you go to professional development, other people are going to be reading this, or you're going to read this a month later and forget what you did. So I learned this as well, even in code bases that I worked on or individually. I use this to track carefully what changes I'm making. And I use staging to only add those changes that really count as a single change that I can describe with a message. So I have everyone not use, don't use Dash M or don't use Dash A, where you commit everything or commit the whole directory. Here, commit whole files, don't use Dash M, and actually pop up the editor. Get used to doing that because you should do this in good practice, with good practice. So I'm not watching you, what you do, but these are the instructions as I've given to you. All right, questions on this so far? So you've seen configuring your Git repository, only do that once a semester. You've seen to create a Git repository, you only do that once per project. And I've shown you the workflow of edit, stage, commit. And you can double check this with Git status. So you can see here, it says working tree clean, nothing to commit. Okay, so this is where we can actually see the contents of the commit. Git show will show you the contents. So here is the commit ID, shows me the author, date, and here's the contents of my commit message. You can see the entire sequence of commits with git log. And that'll be more, yeah.
So as soon as you commit, you know that on you guys' side.
Not quite. So remember, this is the local version of the repository. So git log will show you the rest. So here's how we submit the project. So this is important for grading. So we're going to tell Git the URL of the grading repository. So this is going to be personalized to you. So take this URL. It's going to be personalized to your name or your NID. It has to be your NID plus the name of the project. So I'll give you that information for each project. So for Hello World, it'll tell you that. You just have to replace your NID. So this is telling Git what the grading repository URL for you is for this project. So we add that. We can confirm it with the remote command. So we can see our URL is here. Double check your NID. Double check the name of the project. All right, so there's errors here. All right, so this is how we synchronize. Push is how we synchronize to the remote repository, and you only need to do this once. So this whole sequence of steps is only once. This is how you connect your local repository's set of changes to the remote repository's local changes. So this is saying, take our current branch, which is the stuff we're working on right now, and connect it to this new submission, this new remote repository that I've named submission. So when we do this, hopefully this works, you'll see a lot more information here. It's going to log into Eustace on Eustace 3, and it's going to give you feedback from the remote server. So it's initializing a server initializing a repository on the server, and some information about this change. So it's saying connecting your local master branch to the remote master branch. So it says here, set up to track remote from master. So now in the future, when we run push our changes, they will be added. All right, so let me All right, I got 3 minutes, so if you need to run the class quietly if you can. But I got 3 minutes left. So all right, so let me show you the workflow you need to do once you've created your repository. So let's change this. Let's change this README here. So I've edited README. I've edited the README. Double check through the errors if you get any issues here. Git diff will validate your new changes. So you can see here, I've got my new change. Stage those changes. You can use git status to confirm that they're staged, so changes to be committed. And then commit. And then commit. And this will give you your window again, add a project description. All right, save it. It will, again, confirm that you've made the change. Git status will tell you that your working tree is clean, which means everything's committed. But it'll tell you that your local repository has differences from the remote. It'll say you're ahead of the remote repository. Yeah.
So if you have a file that's already staged and you edit it and you can like you also have to stage
You'll have to stay. I think you'll have to stage it again. Yeah, you'll have to stage it again. So git log will show us our remote local repository. You can see now I've got 2 changes here. I've got my initial change and then my new change here. Git status tells me that the submission to the remote repository is out of sync. So all you have to do to synchronize it is just run git push. No more set upstream. That's already been done once. Set upstream. Git push. And you'll see some statistical information. And now when we run git status, it'll tell us that our working directory is clean and our local branch is up to date with the submission repository. So this screen will tell you that you have submitted all of your changes and there are no remaining changes in your directory to commit. All right, so yeah, we got less than a minute left. So questions, last minute questions. Yeah. It's just connecting your local repository with the remote repository. So the remote will say, here's a URL of a remote. And then when you do set upstream, it'll say, make these 2 synchronize together. So whenever I run push and pull, it'll synchronize them. Yeah. Sorry, I can't hear you anymore. Come on. All right, everyone. I'll see you next time. So this project is started now and due in like a week. Due on 1/22. So do the Git project to get yourself set up with grading. All right, thanks all.